thank you for the nice introduction. I'm Tim, and I'm going to tell you something about workflow engines. A discussion I often have if I suggest to some people that they might benefit from using a workflow engine is, why would I do that? Because it starts with adding a new dependency to your software, and I understand that many people are hesitant to do so if they can solve the problem on their own. So, in general, my answer mostly is because workflows are hard. It doesn't really seem to be that way in the beginning, but you're going down a path there, and if you have some proven engine to support you with that, then it might get a lot easier. To understand why workflows are hard, I would like to start with a short theoretical part. And I want to look at some properties that workflows have. For this talk, I chose this 4. Those are not every property, all properties. And it's firstly humans, it's decisions, it's the sequence of tasks, and it's time. So humans is, I think, pretty self-explanatory. We have humans, we have real people who need to interact with our software. And I think this is often the main focus on software, that people have to use it. Second, decisions. If we have a workflow, which is a sequence of tasks that need to be executed, we might not need to execute all of the tasks all the time. For example, if we have an order process in an online shop for clothes, if the customer in his order process states that he wants to pay via credit card, we do not need to execute tasks regarding PayPal or creating an invoice. Third, the sequence. As I mentioned, a workflow is a sequence of tasks that needs to be executed in order. And we need to make sure that the tasks are executed in the right sequence, or maybe even in parallel, and that we execute when we execute tasks in parallel, that we merge them together at some point, so that one task is waiting for another to be finished, or that they both can start at the same time, but one task takes longer than the other one and needs to wait until the other one catches up. This is an important factor. And lastly, time. How long do we want to wait for something? Or do we even have an SLA that we need to fulfill? So we need to realize if we have a process, for example, a help desk process, it needs to be finished in a certain amount of time. And if we have a way of tracking that and even warning us if the time is violated, then this helps us very much. All of those steps are not really simple. Everything I will explain in this talk, you can do on your own, of course. You can always do everything on your own. And if you just need a subset of it, maybe it's the right decision to do this on your own. But this doing on your own may lead to a path where you are writing your own workflow engine. Many companies have done so. So they started realizing that in all of their applications, they are writing the same code over and over again. And they decided, hey, why not make a library out of this? And we manage the state of our application, we implement the timers, we might even have a framework for user services, so for tasks that need to be addressed by a user, that we make sure that an SLA is met. Why not compile this into a library and just reuse it internally for us? And so over the last years, there were many examples of companies writing their own workflow engine, but they almost every time started implementing business logic into it. So it makes sense if you're an insurance company and you are writing a workflow engine for your processes. All of those processes are insurance processes, so why not put the business logic in there? And then you start to mesh up the logic and the execution, and this can lead to problems when you start to discover a new problem you haven't thought about yet, and then maybe you wish you didn't implement it on your own. You might guess there is a solution for this, else I wouldn't be standing here. There are a couple of popular workflow engines on the JVM that take care for us, of these factors for us. They take care of the state management, they take care of the timing, and take care of building an executional model describing that process. I chose to present Camunda today. This is for two reasons. Because one, I'm using this in at my work, at my job every day, and I kind of know what I'm talking about here. The other reason is Camunda is located in Berlin, and this was rather fitting for today. So there are two other big workflow engines in the JVM area. The first one is Activity, with an I in the end. The other one is Flowable. And Camunda and Activity forked from Camunda and Flowable forked from Activity some time ago. So most of the code I will be showing, you can just exchange the library and use the same code, because they are really similar, and they have forked for some different reasons, but basically they all work the same. All of them are open source, so feel free to use them as you like. Okay. That's about the theoretical part. And now let's see how we adapt this. This is a workflow. This workflow is written down in BPMN 2.0. BPMN stands for Business Process Modeling and Notation. And this is a standard. This is a standard as same as UML is. In fact, both are maintained by the same organization, the OMG. And this is a fixed standard that is not just used for our workflow engines we can use here. The great thing about BPMN, in my opinion, is that even though many of you might not know it, I think everybody is able to understand the process which is described here. So we are starting here with the help desk process. In the upper lane, we have the basic support team. In the lower lane, we have the premium support team. So we start a process, and we are getting some data in it. And then we have to make a decision. We need to decide, is this a premium user or a basic user? If it is in fact a basic user, we will stay in the basic line. We will send an email, which will say, yeah, we got your email. We will probably answer in the next 5 days. Just be patient. And handle it to a low prio task with a bigger SLA. If the user is a premium user, we will send a much friendlier email, which says, valued customer, your issue is very important to us, and we will answer in the next day. And we will handle it to the professional premium team, which also has a lower SLA. You're seeing that this task here has a timer on it. This timer will track our SLA, and if it is violated, or if there is the danger of violating this SLA, then we will just hand it to the pro guys, because they know how to solve this in a short amount of time, and so the customer doesn't get angry. If the pro users, however, violate the SLA, there's no more pro team we can give it to, but we'll just send an email to their bosses so they get mad at them, maybe. After this task is completed, we are waiting either for 7 days to pass, or the user to send feedback, how satisfied he was with our task handling. And then we will archive everything and end the process. So this modeling notation is really, really helpful when you are talking to non-technical people. But that's not the only thing it is good for, because this is also executable. So you are not just writing a model for the model's sake and for documentation, but with this process, you have started laying the foundation of your new software. And you do it with this software. This is the Camunda modeler. This is a great BPMN modeling tool based on an open source software, BPMN.io, which is basically just a JavaScript framework you can embed in your own applications. They made use of it and produced the Camunda modeler, another open source tool based on it. And this is also great if you don't plan on working with Camunda, but just plan on creating these diagrams to document your software. So how does it work? Let's assume we have created our process diagram, and now we want to build a software around that. For this, we need to deploy the application. And as I said, Camunda is per se a Java library, so we will see some interop code here. I'm trying to wrap that away and make a nice Clojure call out of it. So we have, in some global fashion, an instance of our process engine. We have created that. We have added the library to our application. We start it up, and we configure it and tell it which database it should point against. From this instance, we get the repository service, and we get an input stream of the definition file we modeled with the modeler. And then we say, OK, for the repo service, create a deployment from this input stream with this name and deploy it. Or when we have wrapped this once, it's much more readable. This will take this process definition, persist it in the database, and make it executable instantly. So we can already handle this. And we can start a process instance for this process definition like this. We just say, OK, we have the Camunda engine. We get the runtime service. And we say, start process instance by key. We provide the key defining this process. And we add variables. If you take a look at the Clojure code, you realize that these variables are, in fact, a map. This is because Clojure stores all variables internally as a map. We define a key for a variable and a value. And this is really nice if you try to use it from Clojure, because we love maps. And this makes everything really easy for us. We can send in data as maps, we can retrieve the data as maps, and we can modify them as we do with maps. So now the process is running. And the engine handles this process by creating a so-called token. You can imagine a token like this red little dot. And the token just wanders down the path and executes everything that comes in its way. So for example, we are now looking at a gateway. This is what this decision component is called. And the process is started, and the token reaches the gateway. Here we need to define code to tell the gateway which path to take, because it doesn't know it. It could go to the basic support or to the premium support. This code is provided in the modeler itself. You can use in this modeler every language that works as a scripting language on the JVM. So recommended by Camunda is to use JavaScript or Groovy. You could also use Ruby, or in our case, Clojure. So we can really use Clojure code here, and we say if the service type from our variables is basic, then we take the basic path. For any other case, we take the premium path. So this is how we implement this decision. And most important, this decision is visibly for everybody looking at that diagram. It is not hidden away in code. It is not hidden away in some service, but it's just here in plain sight. If we let our token wander along the process further, it will hit a service task. You can see this with those little gears here on the task. A service task is there to execute any work where no interaction of a human is needed. So, for example, database lookups, REST calls, or you name it. Everything you can do just with an input and an output, and it creates a side effect. And these delegates are the reason I started looking into how well Clojure works with Camunda, because if we take a look at how it's done in Java, we see that we need to provide a class for every of those delegates. This class implements the Camunda class Java delegate and implements the method execute. And in the parameter execution, hidden behind that is a map. So for Java, we say, OK, please get the variable first name, and it will return an object, because it's a map of string with a string as a key and an object as a value. Now, what do we need to do in Java? We need to cast it, because we don't know what it is. So we, as a developer, know what it is, but the compiler has no chance of knowing. So we can say, this is a string, and this is a string, and this is a string. And please now send these 3 strings to the mail sender and send an email. And I know why this is built this way. As I said, the compiler doesn't have any chance of knowing what is in this map. But I thought, yeah, you could make this better with a language which is maybe not statically typed. And so I tried implementing this in Clojure. And of course, there's also an ugly part, and this is the interop. We need to implement the same Java interface. This is not ideal, I know that. And this also leads to us needing to precompile this class before working with a REPL, because the engine tries to access this class by name, and if it's not compiled, then the REPL won't find it. I know this is possible. I use it with boot. So boot enables me to set an AOT compiler on the directory, and I can still use it in the REPL. Yeah, but I think this is a low pain, because when we see how the execute method looks like, function, sorry, looks like, we know, OK, we get the map from our execution, and we can apply some deconstructuring and just pass it into the mail delegate, and the job is done. So personally, I like this better. You need to tell the modeler which class you want to link to your service task. So in this case, we just provide the fully qualified domain name, and the engine will handle the call for us. We don't need to care about anything else. So if I go back one slide, we just need to address everything that should happen in this execute function. We don't need to worry about how to interact with other service tasks. We don't care from where we came, and we don't care what the next task is. This is just completely handled by the engine, and we don't even need to think about that. In the beginning, I mentioned the users. And I don't know about you, but I've seen many applications where a user needed to do something with an order. So they open the application, they enter the order number, which they have to know, and then the task for the current order pops up. I don't think this is very usable, and I don't think it's nice to do this to the users. So every time in our process, when a token arrives at a user task or a user service, here with a nice little man in the corner, the token will stop there. It will not execute anything. It will just wait. And it will wait for a user to come and pick this task up. And Camunda offers a task service for us, which we can use to interact with those tasks. So I wrap them again. On the top, we can get the task for a candidate group. A candidate group would be the premium help desk. So I can say, I want to get every task which can be assigned to the premium help desk. And I won't see any basic help desk tasks in here. It's just the tasks that are interesting to me as a user of the application. If I click on a task in that list as a user, then the task is claimed. A claim of a task is like a flag for everybody else in my team to keep their fingers off my task. It's saying, I'm starting to work on that. This is none of your business now anymore. Work on something else. And if a task is claimed, we won't see this anymore in the query for the candidate group, because it is not interesting to the group as a whole anymore. It's just interesting to me as the user who claimed this task. After I claimed it, or even before, I can say, I want to see the task variables. This is all the data stored in the task. So I can render a form for the user, and the user can enter something more. And if everything is done and the data is entered, the user will complete the task while providing an ID and a map of variables. If you call those wrappers, it just looks like this. So a basic workflow would be, I want to have all the tasks for basic support. I will claim the task, number 12, and I'm Tim. I want to get the task variables, and I want to complete the task number 12 with those variables. And with this tool, we can build a nice task list in the user front end, where the user sees everything they have to address, and can just choose what they want to work on there. A nice feature also are timers. And they can be used in one of two ways. The first timer we have here is on the user task. As I said earlier, this timer makes sure that we don't violate any SLAs. Our SLA may be 1 day, and I can set this timer to 20 hours, maybe. And after 20 hours, this timer will fire and close this task. They will take it away from the user, go down this path, and open this task with the premium users. You might realize that the premium users have a similar icon on their task, but with a dotted line and not with a bold line. The dotted line means execute anyway, but don't stop the task you belong to. So this task stays open. The engine creates a new token, which sends the urgent email to the bosses, but the task stays here. Because, as I said, there is no way of giving the task to somebody else. There's nobody left. We can also use the timer in a sequence to tell the token waiting here that they should that the process should stop here for some time. So in our case, we want the process to stop here for 7 days to give the user the possibility to provide feedback. Timers are also, again, configured on the model with some expression that belongs to an ISO code that I just can't remember the number of. And we just say here it's a period of 1 day, so P1D. If that is readable, that's up to you. I could keep going on about features, but I just decided to pick out those 4. There is much more to support you with handling processes. One feature that just doesn't fit in the time frame is process versioning. For example, if you have a process for creating a bank account, and the process is in production, and you have 250,000 processes in production, live, not completed. Then there are 250,000 tokens in different parts of the process. And now the regulators come and say, you need to scan the passport of the user in the beginning and put it in the archive at the very end. So what do? If you start implementing, adding a new user task for scanning the passport in the beginning, then you have many processes which are way beyond this point. There's no way of going back there. So if you edit your file, your process model, and you deploy it again, the engine will version it for you. All the old passportless processes will run in the first version, while all new processes will start on the new version. This is default behavior, and you don't need to do anything about that. The engine does it completely automatic. You can tell the engine to migrate all the old processes to a new standard. For example, if you realize that there is something wrong with legal, and you need to update everything as soon as possible, but the engine will take care of that for you, and this is really helpful and has saved us in production for some times. Let's have a little recap. What I like about the integration of the workflow engine with Clojure is that we have, in my opinion, readable delegates, which just are simple and self-explanatory and in a very atomic fashion. The engine integration is okay if you are willing to implement Java classes and to write Java interop code. The task orchestration is just helping a lot because all the state of this process is just handled for us. We don't need to hassle with quarts to write timers. We don't need to create the user assignments in a database. And we don't need to create batch jobs reacting to timers set in the database. That's just taken away from us, and I'm not sad about it. And we have a unified language, so we can use Clojure in the modeler and in our application, which is not even the case for Java, because you can't script Java in the modeler. So when you work with Java, you have always at least two different languages. So in my opinion, yes, this is a match, and I will continue working with that. If you also think that this is a good thing, I can recommend an event next Tuesday to you. The Camunda user group in Berlin will host Hans Hübner and Robert Packett from Lambda-Werk, and they will talk about Camunda and Clojure. This is completely coincidental. I didn't know about this. I really think this will be a good event. I won't be there because I live in Freiburg, which is the exact opposite of Germany. And yeah, thank you very much. Thank you for clojureD for having me. Thank you to Doctronic for the accommodation, and to my employer, Illume, for providing an environment where this is possible. Thank you.
Microphone. Oh, is it on? Okay. Yes, thank you, Tim, for giving us this comprehensible overview of this topic. And do we have any questions? Yep.
Thanks. What happens if you ever need to break out of this engine? Like if you ever need to do anything, is there a transparent database scheme that you can look at? Is there a way to get at the data, implement stuff?
Yeah, you can always change the data. There is an application provided by Camunda you can add into your class path, which will give you a visual access to the process. So you can even look at all the processes and where the tokens are. But basically, you always need to have in mind that if you pour a process in such a permanent state, so in such an execution framework, then if there is something you have not foreseen, then it might be necessary to end the process and finish it manually. So there's no good way of cutting corners there.
Yeah, thank you for the question. Any more? Yes, I see one more.
So you've been using Camunda to model business processes, like where people are involved. Have you ever considered, or would you recommend using such an engine for like just a program which does just things in different steps after one after the other?
Yeah, that's also possible. Our customers always call this Dunkelverarbeitung. I don't know a proper English translation for that, where there's no human interaction. And one of the founders of Camunda, Bernd Rücker, is also appearing on many stages and conferences in Germany. And he already, also recommends to use BPMN to orchestrate microservices. So there are many more possibilities than just user interaction. Yeah.
Okay, I see one more question over there.
Yeah, thank you for your talk. We at Lambda use Camunda also a lot from Clojure, and I have a question, a detailed question, sort of. Do you do any translation of the variable names when you have Clojure within your scripts, within the BPMNs?
So you're asking if we just access the variable names in the scripts on their own? Or
if you need to do any translation from kebab case to camel case or something like that?
No, we don't do this. We just... it is under our control how we name the variables, and so we can just name them according to Clojure standards if we want to, I guess.
Okay, and I see one more question over there.
Hi. So how do you manage your application state with those, like your components? Because in the Java land there was this inject, but if you have, for example, component or integrand, how do you pass in those into those delegates?
In this case, I just referenced the namespace. So I import the namespace into my delegate and then just use the functions of that namespace. If this answers your question.
Yeah, thanks.
Okay, I do see another question.
Thank you. What does your developer environment look like? Because you have this modeler, but you also need to write Clojure. So where are the parts? How does your repository look?
Yes. The modeler saves its data in XML, which is a good thing, because we just can drop this file in our resources folder. And if we change it in the modeler and we click Save, then this file is automatically updated. So we might need to make a redeployment, or we might need to reload the application. And another nice part about the modeler providing XML, that you can check it into every versioning system you have. So you can track it in Git. So the modeler is just a way of editing that XML that belongs to your application.
Okay, thank you for your questions, and give another round of applause for Tim.
Thank you.